Good evening, Advanced Math. Going to work today on distances and decimals on the coordinate plane. Two things I think you've probably already seen in some problems we've already done. And I want to take the time to make sure I explain exactly how they work. So it's kind of two different things. We're going to work on distances in the coordinate plane and decimals at the same time. So go ahead and write this as the title of your next notes page. And close it up till we get to those we do's where you're going to write them. And just concentrate with me till then. All right, so one quick thing before we start. I want to remind you, at very first when we were working on polygons, we would make a polygon on like a geoboard like this or something similar and start to count the perimeters, like, how long was each side here. A mistake we often made was to count the pegs and say, all right, well, this top side is 1, 2, 3, 4, 5 units long. And then this side is, 1, 2 units long. And we figured out that didn't make sense because when we want to check how far it is across the side here, we don't want to count these. We want to count units of length, right? So like the distance between two of these, that was 1, 2, 3, 4 units long, not 5. If we counted the pegs, we were kind of counting 0, 1, 2, 3, 4. So we ended up counting 5 pegs instead of 4. So that's going to be important on the coordinate plane too, because, well, I'll show you when we get there. So I just wanted to remind you of that. All right, so let's do an easy problem. I'll do an I do easy. So the basic skill is this. Find the distance between the ordered pairs 5, -2 and 5, 5 on the coordinate plane. So this is kind of the most basic type of problem you would see. And it's hard to find their distance without seeing them on the coordinate plane. So I'm going to go ahead and start by drawing my coordinate plane. Maybe. All right. Yeah. This is definitely much easier on graph paper than on non-graph paper where you kind of draw your own plane. I know sometimes you're stuck with that. Graph paper is really going to help here, though. All right, so let me put these two ordered pairs on the plane. 5, 1, 2, 3, 4, 5. -2 is there. And 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 is there. So there are my two ordered pairs. And to find the distance between the ordered pairs, all I'm going to do is count units, like literally just count how many units are between them. Now, much like I said about the geoboard, I'm not counting points. I'm not saying 1, 2, 3, 4, 5, 6, 7, 8. I'm not counting those. That's going to give me too many because I'm counting a non-unit. I'm counting distances, right? So this is 1 unit of distance from there to there. 2, 3, 4, 5, 6, 7. So these are 7 units apart, or the distance between them is 7 units. That's all you have to do is count, but just make sure you don't count points, you count lengths. 1, 2, 3, 4, 5, 6, 7. So that's like the easiest version of that problem. And so I'm going to copy this because I'm going to just slightly alter it in the next question. And it'll save me a little time if I already have this. All right. So let's go to the next one. Let me do a little harder one. And how about this? How about find the distance between 5? I slightly altered the ordered pairs. Instead of 5, -2, it's 5, -2 and 1/10. And instead of 5, 5, it's 5, 5 and 6/10. So I'm going to slightly alter those so that they've got a decimal in the ordered pair, which isn't a whole lot harder, but it's definitely worth me showing you how to do. So those were the ordered pairs I started with. And I'm just going to move them the smallest amount in this problem that I'm giving you here. You know, this one was here. All right, so I just paused for a minute and kind of forgot what I was saying, so sorry if I change direction here real fast. Excuse me. All right, so I'm going to have to move these ordered pairs just a little bit. So this one was at 5, -2, and I'm going to move it to to 5, -2 1/10. So that's a little farther. If you imagine, let me erase it. Imagine like we're zooming in here to put this decimal ordered pair on here. You know, if 5, -2 is here, that's -2, and -3 is here. I don't have a small enough pencil to do this, but if you imagine to cut this into decimals, this is 1/10. You know, you have to kind of imagine I zoom in on this thing, and this is 1 unit, and I would have to partition it into tenths. You know, I can do that: 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. It's too hard for me to actually do that here. You know, they're just too small. But if you imagine me doing that, you know, -2 1/10, I'm going to go -1, -2, and then I have to go 1 more tenth, which is just a tiny bit. If I cut this into 10 pieces, you know, -2 1/10 would be like right there. So I'm going to over 5 and down a little more than 2, like to right there, and say that's 5, -2 1/10. Same thing up here. I'm going to have to go farther than 5, 5. So it's, you know, 5, 1, 2, 3, 4, 5. 5 6/10 is going to be, so I guess I would say 5 5/10 would be there, like halfway between 5 and 6. Make sure I'm in the right place. 5 and 6. 1, 2, 3, 4. Yeah. So 5 6/10 is a little past 5 5/10, a little past 5 1/2. So I'm just going to put it kind of right there. That's 5 6/10. All right, so now if I want to find that distance, you know, if my old points were here and here, and those are easy to find. It was, you know, 1, 2, 3, 4, 5, 6, 7. So it's 7 from the nearest whole points, kind of, if you want to think of it that way. It's too small of a pen. So, you know, this is 7. And then this little bit right here is 6/10. And then this little bit right here is 1/10. So it's really just going to adding all those together. So I went 1/10, then 7, then 6/10. So all together, the distance between those two ordered pairs would be 7 7/10 units. I don't know that you're going to see any problems like this involving decimal ordered pairs, but just in case you do, I wanted to show you how. It's not really too much harder. You just have to be logical and break that distance into parts. The decimal, then the whole distance, then the decimal. All right? So we're going to do, I'll have one of those for one of your you-dos. We're not going to do one of those for a we-do. So let's do a we-do. This is kind of a real situation kind of problem. So open your notebook, and let's work this together as a we-do. So this says, the diagram shows the locations of Gabe's house, here, a library, and a gymnasium. Each unit on the grid represents 1 kilometer, so it's like 1 kilometer here, 1 kilometer here, and so on. On a particular day, Gabe walks from his house to the library, then to the gymnasium. What is the total distance that he walked? So we're just going to count the distance that Gabe walked from his house to the library to the gymnasium, and we'll know. So he starts here. Remember, we're not counting points, we're counting line segments. So it's 1 kilometer. This is 0 kilometers. When he gets to this point, he's walked 1 kilometer. So he's walked 1, 2, 3, 4 kilometers to the library, and then 1, 2, 3, 4, 5 more kilometers to the gymnasium. So 4 here and 5 here. So Gabe has walked 9 kilometers. That's kind of a typical distance problem in the coordinate plane. No decimal or anything like that. But I did want you to understand the decimal part too. So we'll do a decimal one, another problem like this in your UDO tomorrow. And then we'll also do a decimal one. So if you need to go back and review how to do that decimal one, if that seemed hard to you, go ahead. If not, you're all set. So that's how you find distances and deal with decimals in the coordinate plane. After you have this one nicely explained in your notes, you're all set. See you tomorrow.